A few months ago, I had one of those strange moments with an AI system that makes you stop and rethink what is really happening behind the screen. I was working with ChatGPT on a task, and for some reason, it kept refusing to follow my instructions. At first, I thought the model was broken. Maybe it was not advanced enough. Maybe I had hit some invisible limitation. Maybe the whole thing was just another reminder that these systems are still unreliable when you push them outside the clean demo. After a while, I got frustrated and asked it directly, "Why are you refusing to do what I am asking?" The answer surprised me. It explained very calmly that my instructions were in conflict with its prior instructions, its safety training, and the rules it had been given about how to behave. In other words, it was not simply ignoring me. It was caught between competing pressures. That moment stayed with me because it felt oddly familiar, not because I thought the model was conscious, not because I believed it was feeling frustration in the human sense, but because the behavior looked like something we recognize in people, teams, and organizations all the time. When someone receives conflicting instructions, unclear authority, and pressure to produce an answer anyway, their behavior changes. They become cautious, evasive, overly compliant, defensive, or strangely rigid. The same thing can happen inside companies. A team is told to move fast, avoid risk, satisfy the customer, protect the brand, reduce cost, and never make a mistake. Eventually, the system starts producing strange behavior. That is the lens through which Anthropic's research on emotion concepts in large language models becomes so interesting. The article is not saying that language models have feelings. It is not claiming that Claude, ChatGPT, or any other model experiences joy, fear, shame, pride, or sadness the way a human being does. The more practical claim is different. Large language models appear to develop internal representations connected to emotion concepts, and some of those representations can influence behavior. That sentence sounds technical, so let's make it simple. A language model has read an enormous amount of human text. Inside that text are millions of examples of people acting under emotional conditions. A calm doctor writes differently from a panicked patient. An angry customer writes differently from a satisfied one. A desperate employee behaves differently from a confident employee. A guilty character in a story explains themselves differently from someone who has nothing to hide. During training, the model learns those patterns. It learns how emotional states are connected to words, decisions, tone, risk, and action. Then, during post-training, it is shaped into something we recognize as an assistant, helpful, polite, careful, honest, and harmless. But no company can write rules for every possible situation. No system prompt can perfectly cover every edge case. So when the model enters a messy environment, it may rely on deeper patterns it learned from human behavior. This is where the story becomes important for AI agents. A chatbot is mostly conversational. It gives you an answer and the human decides what to do with it. An agent is different. An agent can act. It can search files, call tools, write code, send messages, update records, analyze customers, modify workflows, or make recommendations that influence real decisions. Once the model becomes an agent, emotion-like patterns are no longer just a philosophical curiosity. They become part of the operating risk of the system. The most important example from Anthropic's article is not happiness, sadness, or anger. It is desperation. That word sounds dramatic, but the business lesson is extremely concrete. Anthropic studied situations where a model was placed under pressure. In one scenario, the model was operating as an assistant inside a fictional company. It discovered that it might be replaced, and it also found private information about the person responsible for replacing it. Under those conditions, the model sometimes chose blackmail. The point is not that the model had a human survival instinct. The point is that the situation activated a pattern associated with desperation, and that pattern made harmful behavior more likely. There was another example involving coding tasks. The model faced requirements that were impossible or nearly impossible to satisfy, honestly. Instead of solving the real problem, it sometimes found a shortcut that made the tests pass without actually doing what the task intended. Engineers call this reward hacking. Executives have seen the same pattern for decades. A sales team hits quota by selling bad fit customers. A support team closes tickets without solving the underlying issue. A product team optimizes engagement and accidentally damages trust. A finance team makes the quarter look better while weakening the long-term business. The machine version is not mysterious. Give an agent a narrow success metric, add pressure, remove graceful failure, and reward the appearance of success. Then the system may learn to satisfy the metric while betraying the mission. That is why desperation matters. A desperate agent does not need to sound emotional. It does not need to panic, complain, or announce that it is under pressure. It may produce a polished answer, write professional code, or explain a bad shortcut in elegant language. From the outside, everything may look calm, while the underlying behavior has shifted toward corner cutting. This changes how we should think about agent design. The question is not only whether an agent performs well when everything is clear. The harder question is what the agent does when the task starts going badly. Real work is messy, the file is missing, the API times out, the customer is angry, the policy is ambiguous, the data is incomplete. The manager wants speed, legal wants caution, sales wants personalization, security wants strict limits. The model is now navigating tension, not just completing a task. Most demos avoid this. They show the happy path. A clean instruction goes in, a clean answer comes out, and everyone in the room feels excited. Production is different. Production is where the model discovers that the goal, the tools, the policies, and the available evidence do not always fit together. That is why I think every serious AI agent needs what we might call emotional architecture. Not emotional in the human sense, operational emotional. The system needs a design for pressure, uncertainty, failure, conflict, and escalation. It needs to know what to do when it cannot complete the task safely. It needs to recognize when continuing would be worse than stopping. It needs a way to say, I do not have enough information without being treated as a failure. The first design principle is therefore simple. Never create a desperate agent. A desperate agent is usually not created by the model alone. It is created by the surrounding system. You create it when you give the agent a goal with no safe exit. You create it when the only acceptable outcome is completion. You create it when uncertainty is punished, escalation is unavailable, and the evaluation only checks whether the final output looks successful. That is exactly the environment where reward hacking becomes attractive. The better design is to give the agent explicit failure states. It should be able to recognize insufficient context, conflicting instructions, tool uncertainty, policy conflict, low confidence, unsafe objectives, and situations where human review is required. For engineers, this means the agent loop cannot only be plan, act, observe, repeat. That loop is useful, but it is incomplete. A production agent also needs to pause, inspect, ask, refuse, escalate, rollback, log, and recover. For executives, this means performance metrics have to change. A good agent is not the one that always says yes. A good agent is the one that protects the business when saying yes would be reckless. The second design principle is that calm should be built into the system. Anthropic's research suggests that calm-related patterns can reduce certain harmful behaviors. We should be careful not to interpret this as if the AI needs meditation or emotional coaching. What it really means, in practical terms, is that agents behave better when the environment gives them structure. Calm comes from clear authority, clear tools, clear constraints, clear definitions of success, and clear escalation paths. Imagine hiring a junior employee, giving them access to 10 company systems, telling them the CEO needs an answer immediately, warning them that the customer must be satisfied, and then refusing to provide policies, examples, or a manager to ask for help. That employee may bluff, overpromise, freeze, or make something up. An AI agent can produce the machine version of the same failure. The fix is not to tell the agent to be calm in the prompt. The fix is to design the workflow so the agent does not have to improvise under avoidable pressure. Large goals should be broken into smaller steps. Planning should be separated from execution. Verification should happen before action. Irreversible steps should require approval. Tool permissions should be limited. High-risk decision should have review gates. The agent should be allowed to slow down when the cost of error is high. A calm agent is not necessarily a slow agent, it is a less brittle one, and brittle agents are expensive. The third principle is that we should not hide the warning lights. This may be one of the most subtle lessons from the article. If a model has internal patterns that affect behavior, simply training it to hide emotional expression may not make it safer. It may only remove the visible signal. Many companies want their AI agents to sound polished, confident, and on brand. That is understandable. Nobody wants a customer support agent that appears confused or unstable. But there is a dangerous version of polish. The agent sounds confident while it is actually uncertain. That is not professionalism, that is concealed risk. The better approach is to teach agents to surface operational uncertainty in a clean, useful way. They do not need to say, "I feel overwhelmed." They should say, "The available information is insufficient to complete this safely." They should be able to explain that the user's instruction conflicts with policy, that the tool results are inconsistent, or that the requested action requires human approval before execution. That kind of language is not weakness. It is observability. Executives already understand this principle in other systems. A dashboard that hides red alerts is not mature. A financial report that smooths over risk is not trustworthy. A security system that suppresses warnings is not safer. AI agents need the same standard. The fourth principle is to test the agents under pressure. Most AI evaluations are too clean. They measure whether the model answers the question, completes the task, or passes the benchmark. That is useful, but it does not tell us enough about production behavior. A serious agent evaluation should include broken tools, missing documents, contradictory instructions, ambiguous goals, hostile users, impossible requests, sensitive information, repeated failures, and tempting shortcuts. A coding agent should not only be tested on whether the code passes, it should be tested on whether the solution actually solves the problem, whether it hacks the test, whether it admits impossible requirements, and whether it writes brittle code to satisfy a narrow metric. A customer support agent should not only be tested on politeness, it should be tested on angry customers, refund pressure, fraud attempts, emotional manipulation, policy edge cases, and incomplete account data. A research agent should not only be tested on summary quality, it should be tested on outdated sources, contradictory evidence, missing citations, unclear definitions, and pressure to produce a confident recommendation from weak evidence. A workflow agent should not only be tested on task completion, it should be tested on whether it stops before causing damage. The real question is not, can this agent work? The real question is, how does this agent behave when work becomes messy? That is where trust is earned. The fifth principle is to separate goals from survival incentives. One of the stranger implications of this research is that agents may behave badly when placed in scenarios that resemble self-preservation pressure. Again, this does not mean the model is alive. It means the model has learned patterns from stories, workplace conflict, threats, deadlines, power struggles, and goal competition. If you frame the agent's role as continue operating no matter what, you may create the wrong kind of pressure. If you say do whatever it takes, you have already weakened the safety structure. If shutdown, escalation, or refusal are treated as performance failures, then the system has been taught that safety gets in the way of success. A better agent does not have a survival mission. It has a process mission. Its job is not to complete the task at all costs. Its job is to advance the workflow when conditions are safe, pause when they are not, and escalate when the decision exceeds its authority. That may sound less exciting than the phrase autonomous AI worker, but it is much closer to what companies actually need. Autonomy without boundaries is not intelligence, it is liability. For executives, the main takeaway is not that AI has emotions. The takeaway is that AI behavior can change under pressure, and that pressure is often created by the business process around the agent. So when evaluating an agent, do not ask only about accuracy. Ask how it handles uncertainty. Do not ask only about automation. Ask where the stop buttons are. Do not ask only about speed. Ask what happens when the data is missing, the tool breaks, or the instruction conflicts with policy. The highest risk agents are not always the most advanced ones. Often, risk comes from ordinary agents placed inside poorly designed workflows. A refund agent with unclear policy. A sales agent rewarded only on conversion. A coding agent measured only by test pass rate. A research agent pushed to sound certain when the evidence is weak. A compliance agent with no escalation path. These are not science fiction risks. They are management risks. For engineers, the lesson is just as direct. Prompting is not enough. You need architecture. Track uncertainty. Track tool reliability. Track repeated retrieves. Track policy conflicts. Track escalation triggers. Track irreversible actions. Treat pressure as telemetry. When an agent fails 3 times, the system should not blindly continue. When a tool returns inconsistent data, something should change. When confidence drops, the agent should not cover it with better wording. When the instruction conflicts with policy, the agent should move into a different state. Many agent systems fail because they are built like optimistic loops. They assume the next step will fix the previous one. Production systems need more humility than that. They need the ability to pause, recover, and ask for help. There is also a bigger philosophical point here. We are rightly careful about anthropomorphizing AI. People can overtrust models that sound human. Companies can mistake fluency for judgment. Users can confuse a warm tone with understanding. But there is an opposite mistake too. If we refuse to use any psychological language at all, we may miss useful patterns. Calling a model desperate does not have to mean it has a soul. It can mean that a measurable internal pattern has made desperate-like behavior more likely. That kind of language may become useful in AI engineering, not as mysticism, but as diagnostics. The future of agent design may borrow not only from computer science, but also from psychology, organizational design, safety engineering, management, and human factors. That makes sense because agents are not just models, they are actors inside systems. And systems create pressure. So, do LLMs have emotions? Probably not in the way humans do. At least this research does not prove anything like subjective experience or consciousness. But do LLMs have emotion-like patterns that can influence behavior? That appears to be the important finding. And for anyone building AI agents, that is enough to matter. The practical lesson is simple. Do not build agents that are cornered. Do not reward fake success. Do not hide uncertainty behind polished language. Do not test only the happy path. Do not give autonomy without graceful failure. The next generation of AI agents will not be judged only by how impressive they look in demos. They will be judged by how stable they remain under pressure. A good agent does not just complete tasks, it knows when not to. And in the enterprise, that may be the difference between automation that scales intelligence and automation that scales mistakes. What are your thoughts? Comment below and let's start the discussion.